Thank you for attending, and specifically thank you for coming to this specific talk. My name is Naira. I'm an ML engineer, and today I'm representing my company, MindBase Information Technologies. And the title for today's talk is NLP and graph-based product tracing in supply chains. So for the start, let's take one step back from this very complicated naming, and let's try to understand the problem that we're solving. In your everyday life, you're entering a shop, you are going to the shelf and taking a product. At that moment, when you're taking the product into your hands, you may have a question. How did this product end up being in this specific shop? What kind of product even is this? How it was produced? And why do we see the price that we are seeing on the shelf? And with this system, we're trying to answer these exact questions. Let's start and see what kind of information we have, and what we did with that. So for the start, we have three different raw data sources. We have final retail receipts, we have B2B invoices, and we have customs declaration. At the first sight, these three raw data sources may seem very different because all of them have company identifier, product description, price, and some other identifiers. However, in real life, they are very, very different because, for example, in customs declaration, the product description has very complicated custom-specific terminology-heavy words. In B2B invoices, we might have very company-specific information that may not be reflected in receipts or customs declaration. And in receipts, we oftentimes have short and very messy information. So what is the problem in here for us? We need somehow to make sense of all of these three data sources and actually connect them with each other. The next problem that we were facing is the scale. We're not working with isolated couple of very good transactions. We're actually working with millions and millions of documents from three very different sources. So here we're trying to solve multiple problems. First, we need to understand what each transaction shows, and we need to do that on scale. At this level, a human agent cannot produce any meaningful information. That's why we need an automated system using ML methods. So since the problem was very complicated at the start, we decided to break this into multiple blocks, multiple explainable and understandable blocks. First, we're receiving the raw records. As I already told you, the raw records are very messy, and at the first step, we are normalizing them, we're bringing them into one forward and doing all of that very not interesting stuff that ML engineers do. On the second step, we have the NLP pipeline. In here, we're analyzing the transactions, we're analyzing the products, and we're trying to make sense of the products and understand what kind of product is that. On the third step, we have the transactional graph. On this step, we're constructing the transactional graph, and this is the exact step where we understand how different companies are connected with each other. And the final step is the analytical step. At this step, we're showing the user the final result of all the work that has been done. I need you to understand that each of these steps is necessary for each other, because if we only have a graph, we have transactional information, but we do not know about what is that transaction. If we have only NLP, we have a lot of product information and we don't know which companies are selling them. And if we don't have the final analytical layer, we've done a big job, but the final user cannot make sense of our job because they are not engineers. So let's look at the first part of the system, the NLP part, in a closer detail. In here, we're dealing with very fragmented transactional data. So let's take a look of a very simple example. Here we have receipt line cola with K 0.5 liters. In invoices, we might have Coca-Cola 500 milliliters, and in declarations, we might have soft drink Coca-Cola 5,000 liters. So here we have a lot of problems. One of which is trying to understand the misspelled words, because for a human, this is very understandable that it is the same product. But for the system, you need to bring all of this information into one explainable place so you can connect them. So basic database joins are not working in here. Another big problem is that retail prices and declaration prices are very different, because in retail we're selling in small packages in small prices, while in declarations the companies are importing products in millions and millions of dollars and other currencies. Another big problem we have is the unit normalization. Because in customs declaration, the companies, when they're importing goods, they're importing in tons, they're importing in liters, but at the end, when we're buying a product, we're buying by a piece. So we need to somehow make sense if that one piece was sold, which part of the 5 tons that was imported to the market are actually being sold. Basically, we have very messy text, we have unit mismatch, we have brand misspellings, we have product misspellings, and we need to somehow make sense of all of this. Here we have visualized the example of what can receipt look like, and we have here the NLP result. As you can see, we have the pricing here. We might even have the unit measure in the receipt itself. But the main information that we're trying to get is actually written in the text. And we need to do a heavy text analysis on all of the transactions to understand what is going on in the market. This example is actually a very nice and very beautiful example, because everything is written in understandable language. It is written in one single language. There is no wording issues. But in real life, we get transactions when one product description can have multiple languages. It can be written both in Armenian, in Russian, in English, and that is all in one sentence. The most basic example is that usually people write the product name in one language, and then they write the brand name in English, because that's like English brand. So in here, what we're trying to do, we're trying to receive the signals from the products. And the most important signals that we understood that we need for this system was the categories, the brand, and unit. For the categories, for attaching categories, we've used semantic models. With the semantic models, we retrieved information from the textual part of the transactions, and then tried to bring all of that information retrieved about product into unified and predefined categories. For categories, we have a hierarchy, which lets the user to use different scales for the later analysis. For the brand, we also have a lot of big problems, because as I already told you, you can have a lot of misspellings in the brand. For example, we have a perfect example in here is that San Pellegrino. San Pellegrino is written with, originally in Italian, it should be written with double L. But we have millions of rows when it's written in one L. It is written with horrible misspellings. It is written in Armenian, in Russian, and then we need to somehow unify them. So in this part, our problem is not only extraction, our problem is also normalization, to make sense that all that misspelled San Pellegrino is actually one single product. And for these purposes, we're using predefined categories and brands to hierarchically understand whether that brand makes sense in that product category. And next stage is the unit. And the unit part is very interesting, because with all of the transactions, we are getting units, unit measures. However, that unit measures are not actually useful for us, because, for example, in here you have packaging of 12 bottles, but the actual transaction will tell you that you have sold 1 unit, because you actually sold 1 unit of one package. But we're actually interested on the inside side, how many bottles we actually sold, because the importer imported X amount of bottles, and we cannot just say that we sold 1 unit, because that's actually not a 1 unit, it's a 12 unit. At this stage, we are heavily analyzing the textual data. We're heavily trying to understand what are transactions telling us. We're attaching predefined categories, brands, and units, and then we're moving on to the tracing part. Okay, so first part of the tracing, we have actually two different tracing systems. First tracing system is answering the first question from the start of the presentation, how this specific product end up in this specific shop. We are getting the structured data from the NLP that we have discussed already, and from the user we are getting the seller ID that they're trying to examine, the product identification, which we're identifying as a category and brand pair, and we're getting a date range. With this information, we are filtering this information because, as you remember, this is millions and millions of transactions, and we cannot just load that much information into the memory because obviously we also have hardware limitations. After filtering all of the products, we are constructing a product graph from the transactions. So let me explain what actually this product graph shows. In here, the edges are the companies, the nodes are the companies, and the edges are the transactions among them. So why do we actually need this graph? Because all of this transaction information is stored in tabular data, and making sense of this data using tabular information, doing tabular joins, is getting exponentially big, and it cannot be handled with any hardware. So we needed to come up with kind of solution that would help us to reduce the scale of that, and the graph methodology was very useful for that. So we are constructing the graph with companies, and then with the chosen seller ID, we're trying to understand what kind of connections it has. So for this specific one, you can see the connection graph around it. And that from that connection graph, we are then to that connection graph, we're attaching the information that we got from the NLP pipeline. Why this part is very important? Because two companies may have a lot of transaction with each other, and that even might make sense that one company was supplied by another company, but that actually is not true. So for example, in here you can see real connections. Well, that's not real. This is synthetic examples, but you can see connected transactions which actually do not have the same product, but they are connected. They are connected because they have transaction with each other. Our main goal in here is finding the pet, where we found the pet and we have the transaction, but we also have the supportive data from the NLP pipeline, and we are sure that the transaction is showing the exact product that we need. As you can understand, here we might produce a lot of pets, but since we cannot examine all of pets, after finding the most probable path with the shortest path algorithm, we are using the information from NLP, and we are doing the initial analysis to understand whether that path actually makes sense, whether the amounts make sense, whether the date range makes sense, and if we have heavy variations, this most probably doesn't mean a fraud, but means that we found the wrong path. As you can understand, the shortest path is not always the true path. That's why we're always looking into multiple possible paths. In here, we can see a very simplified example of how a path can look when one company is importing a product, Samsung TV, and another company is buying that product from the importer, and then it is supplying to the final retail seller. This is actually like the most classical thing that we're seeing in the market, and this can have two edges. So for example, the importer is the supplier itself, and this can even have one edge when the same person is importing and then selling retail. And let's have a look at final information that we're reporting. We're reporting all the importance of the chosen product, olive oil magic. This is example for presentation purposes. Then we're reporting the path that we're actually exploring. We're reporting the unit price at each stage of the life of the product. We're reporting the amount of imported products, the supplied product, and the sold product, and then we are reporting the marginal changes. Here we have some kind of additional information, which I will not go into detail because we're short on time. At each step, one single anomaly at a single line doesn't mean that we have a fraud. But when multiple signals are telling you that there's something wrong, then you might need to look into further into that specific companies. And then we had another question for our company. The question was that, well, if we can analyze one single seller, if we can analyze one single seller, one single product, why we can't just do a full-scale market analysis? And then we come up with general tracing. So in here, the user only chooses the product with category and brand pair, and then we produce the whole market analysis for that. This actually helps to understand. Let's again take the example of olive oil magic. We understand the major importers. We understand the major suppliers. We understand how the product moves to the market. And in here, we're trying to see whether there are very suspicious movements. Why do we have so many suppliers around the way? Because this is very suspicious behavior. And in this way, user can analyze the whole market, and when they see a suspicious behavior, go back to the product tracing one and see whether they need to investigate further into some companies. So for this, for general tracing, we're reporting all of the importers of the products, all of the suppliers, and all of the sellers. And again, we're reporting analytics on the life cycle of this product. Is the unit price at each stage of its life cycle, the whole imported supply that sold amount and the marginal price change. Please pay attention in here that we have a very differing number in imported that supplied products. This does not automatically mean that we have a fraud, because this specific product, olive oil, might be used in production, and you might find if you take a closer look, you might find out that you don't see a supply because they use the product in transaction. So again, I want to emphasize that this system is a helper for an actual investigator. When this system is signaling multiple fraud possibilities, then it is a signal for the real investigator to go and take a deeper look on the market, on the specific seller. And let's finalize and with 4 very important things that we learned from this project is that NLP is the foundation for tracing, because before trying to understand how the companies are connected, we need to understand what are they selling. Because if we understand that the companies are connected, but we don't see how they are connected, then this information is useful. The second is that the graph makes fragmented transaction explainable as path. This teaches us that we should always try to find some ways to look at the tabular data in a different way. And in that way, we might solve a really big scalability issue, and we might have really great findings. Third is that anomalies are stronger when text, price, quantity, and structure agrees. Is that one single anomaly doesn't mean automatic fraud, but when you find multiple anomalies in a single analysis, that is a really big signal to go and take into the closer look. And the final one is that for the real world problems, real world data, simple and explainable systems are far more interesting and far more better than what we see in today's world. Because in today we have this strong urge to fill everything into an LLM and give one big solution. But when you create systems that are modular, that solve one problem at a time, you create a trust. a trust where an investigator who is not an engineer will trust into your system and will not look at your system as an ununderstandable black box system. Thank you everyone for your attention, and I will be happy to hear your questions. Do we have any questions? Yes.
Thank you. Thank you for a speech. My question was in the graph representation. When you said like the nodes were the companies, you didn't quite mention like what was the edges there that we see. Are those the specific transactions that they made, like with the date included? Or it's the deals that they have, they usually do transactions? This
is the actual transaction. So if there is a transaction between the two companies, then they are connected with edges. And then when we find the connection, we are filtering that connection using the information that we received from NLP.
So there can be like multiple transactions between the same companies, right?
Yes.
So they can have like
yes, of course. And actually, I didn't draw very complicated graph in here because we have a lot of relationships. We have circular relationship, one company selling to another and then back to each other. The graph is actually far more complicated than you see on the image.
Thanks.
Thank you for your talk. I was wondering what other structures that did the full graph had. Do you find anything other than simple paths interesting in that?
Well, first we took the approach of going with the simplest path because that's what we're always told. When you have a graph, you should always look into the simplest path. But then we started to notice that there are paths that are extraordinarily long, and they are actually not a mistaken paths, and they are actually a fraud paths. And using the long paths, we found a fraud where one important was selling to supplier, then another supplier to selling another supplier. They have around 5 suppliers, and then doing a closer analysis, we found that all of that suppliers are actually belonging to the same company. And that is an actual fraud. So basically, we after doing this thing, we actually analyzed and try to understand what we should actually report to the users so they can find the fraud. And now we're not only reporting the shortest paths, but we're also reporting the paths that are long, but analytically they are making sense. Yes.
I was wondering, can you please elaborate a little bit more of how you build this graph? Are you taking as an input, do you receive the IDs of these companies, or are you using them as an output from an NLP step where you are?
When we receive the data, we're receiving company identifier for the B2B invoices. We have company identifier. This is actually not so correct representation, because for B2B invoices, we have company identifier for the company who supplied and the company who bought the product. And using the information in this transaction, the company identifier and these transactions, we're making this connected graph. Because someone is importing, and then actually the main transactions that are constructing the graph is the B2B invoices.
Yeah, hi. Thank you for your talk. It was really interesting. I wanted to ask about fraud detection. So you build these graphs, you have this data, and what triggers the alarms that there is fraud? What signals do you use to understand which is fraud and which is not? Well, I mean, a person can look at this and make this decision, but if we try to scale this system, we need some automated alarms. So I wanted to ask if you have such thresholds or main signals.
Yeah, so basically this system works the best for the products that have an actual life limitation on the shelf, because that makes sense. For example, if you're looking into milk, you cannot just buy a milk and keep it in the warehouse for years. But then we have other signals that, for example, we see that for the specific time range, some seller was supplied, let's say, 5 liters of olive oil, and then we don't see any sale, and then we see continuous supply, and then we don't see a sale, which is a very strong indicator of a fraud, because why are you buying a product if you are not selling it? And we found a lot of things like this, a lot of minor things, because before giving the system to the user, we gave them a big manual of what actual small signals we found and how to actually use the system to find these signals. So you can actually start the analysis for 1 month, and then do 2 months, and then 3 months, and see that the supply is rising, but this is a specific example that the supply is rising, but the sales are going down, and that is a big identification of a fraud. So someone is not printing receipts to avoid taxes.
Thank you for the presentation. Have you faced with some collisions in your graph? For example, any collisions, for example, circles, and how do you solve this?
Well, as I already told you, we put here very simplified graph, but we actually did some collisions, because there are many cases that the same company is the importer and the supplier and the a final retail seller. So for solving this specific case for the product tracing, we actually started from the seller. To avoid this collision, we started from the seller and started going backwards. So if we started from the important, the paths may get really big, and that is what we see in general tracing. But when we started with the important and started going back from the important and doing the filtration after each step, so when we drew a graph for supplier, then we did the filtration with categories and brands, and then we attached the declarations to make the collisions as limited as possible. And at the end, when the collision still happened, it mainly happened when we had this general tracing. We analyzed the collided paths. We did the final analytic parts, which report you can see in here. And we just compared which one of them makes sense. So the path actually has to make sense, because if the path is like very heavily diverging, that doesn't mean a fraud. That means that we made a mistake. So one very important thing about this system, that we do not expect the system to work automatically. We don't send fraud signals to companies. This system should be used by a human agent to evaluate all of the information that they cut.